This is to provide overview, to supplement our reading and our mind tap exercises on the carbohydrates, sugars, starches, and the fibers. So we've just studied a bit about diet planning and an overview of digestion, and now we'll start to talk about individual nutrients to give us a stronger foundation of them. We'll talk about the three macronutrients when today starting with carbohydrates. And here's a chemist's view of the macromolecules. We'll be studying carbohydrates. You see monosaccharides and one disaccharide shown there. We'll talk about the lipids and all about their structure, their digestion, their absorption. We find them in certain foods. And finally, we'll talk about protein. As we're in our initial discussions, we know that serving size is very important in consideration in diet planning. And I came across this nice little tip on serving sizes. If you want to estimate by eye, a cup is about a fist, and the palm of our hand, a common measurement for a serving size, is 3 ounces. And a single ounce, you might look at your thumb as a single ounce. Just a little tips there. Okay, our objectives in chapter 4, carbohydrates, to identify monosaccharides, disaccharides, polysaccharides, common in nutrition and their chemical structure and major foods sources. We'll summarize digestion of carbohydrates and their absorption, explain how the body maintains blood glucose concentration and what happens when glucose rises too high or falls too low, describe how added sugar can contribute to health problems, and identify benefits of recommendations for starches and fibers. So to warm us up, carbohydrate introduction. The brain uses carbohydrate as its primary energy source, and that's glucose, monosaccharide glucose. The goal of digestion and metabolism of carbohydrates, making glucose. Muscles store simple sugars in the form of, that's the other important G word, glycogen. Chemist's view of carbohydrate. On the left, we have carbohydrates. Complex carbohydrates are what? Well, they're polysaccharides. Sucrose, common table sugar, that's disaccharide. Galactose, that's a monosaccharide. Lactose, milk sugar, is a disaccharide. Fructose, another monosaccharide. Maltose, disaccharide. And the other very important monosaccharide is glucose. Our structures of carbohydrates, they are made of carbon and oxygen and hydrogen. So being carbon-based, of course, they are organic. And they're linked together in bonds. They're called covalent bonds. Carbons always connected with carbons, and hydrogens coming off the carbons and also off of oxygen bonded to carbons. So you might remember from chemistry, carbon always has 4 bonds to it. oxygen 2 and hydrogen 1, just as we're looking at some of the structures. So monosaccharides, these have the same number and kinds of atoms as we look at them, that is the carbon, hydrogens, and oxygens. However, because of the way that they're bonded and their spatial configuration, they differ in their sweetness and some of their other characteristics. Glucose is also known as blood sugar. This is the essential source of most of our energy, especially our brain and nerves. And glucose is a part of every disaccharide. You see that. Fructose, commonly you see on prepared foods, processed foods. You see fructose or high fructose corn syrup. This is used in preparing food, processed foods, because it's relatively inexpensive compared to the sweetness punch it delivers. Galactose, not found, that monosaccharide is not found in many foods. However, it's a component of one of the monosaccharides, disaccharides that we'll see. The structure of sugar, they're 6-member rings of 5 carbons and 1 oxygen. That's shown here. And see, oxygen is a member of the ring, so these are called ring structures, and that's glucose that we're looking at. There's different ways to portray this. This as a chemist's view. These are all the same, representing the same thing, but they could be shown in a more detailed way or an abbreviated way, more abbreviated, the one on the right. The other monosaccharides, in comparison, you see fructose there on the left and galactose on the right. So you see slight differences in their bonds and difference between glucose and galactose. You'll see just it's an isomer of having an OH in a down position versus an up position in relation to the rest of the ring. The disaccharides, these are pairs of monosaccharides. Maltose, sometimes called beer sugar, it's in fermented beverages. Sucrose, or table sugar, and lactose, milk sugar. Now these are bonded monosaccharides, and the way these are bonded where they come from, they're bonded by a process called condensation. This is the way that the monosaccharides are linked, and we actually do some of this also in our bodies when we store sugars as glycogen. The opposite of condensation is hydrolysis. We have to break down carbohydrates to absorb them. And the way we do this is via the chemical process called hydrolysis, that is adding sugar to break down a bond. And we show that here. Water is actually added across the linkage there, right there, the oxygen linkage. The ether linkage is water is added across, and then we have the monosaccharides. So this is an example of hydrolysis of maltose. Polysaccharides, that's more than 2 monosaccharides linked. Glycogen and starch are examples of polysaccharides. Glycogen is the storage form in animals. whereas starch, a similar type substance, but this is the storage form that's in plants. If starch is in plants is highly branched, it's called amylopectin, and if it's not branched, unbranched, it's called amylose. So, and um, this has implications as to how we digest the starch, whether it's branched or unbranched. And this is what the glycogen looks like on the left, straight and lots of space. Lots of space allows for water molecules to be in between the spaces. So when we store glycogen, we also store a lot of water. When someone is trying to store glycogen, perhaps for an endurance event, athletics of some type, if they're overdoing the glycogen storage, they might feel stiff, and that's because it's storing a lot of water along with the glycogen. And I feel a little bloated. The starch is more compact, the amylopectin, and the amylose also, and it takes a form of a twisted chain. So fiber, dietary fiber is long chains, and we call this complex carbohydrates. They differ from starch in that you see the starch molecule has a particular linkage there that animals can and we can digest. We can break this up, whereas we don't have enzymes to digest in the same manner the cellulose. So the cellulose is the dietary fiber type of carbohydrate. That is the carbohydrate that we can't break down, so that serves as fiber. It doesn't digest well, and it then goes through the digestive tract in the form of soluble and insoluble forms, depending on the particular source of the cellulose, that it could be more soluble or insoluble. And we'll discuss a little bit about the advantages, benefits of fiber. The ultimate goal of carbohydrate digestion is the absorption of glucose. Carbohydrate digestion starts right away to some extent in the mouth because the salivary enzyme amylase works to begin the starch digestion. The activity of the amylase diminishes in the stomach due to the high acid acidic component in the stomach, as we saw in the digestion overview discussion earlier. If fiber is present in the stomach, it delays gastric emptying, and that has some advantages, as you could think about. If we slow down the digestion, you might feel fuller, might slow your eating down. It also would slow down the emptying so that digestion could be more efficient and complete. So the answer. The majority of carbohydrate digestion is in the small intestine. The majority of the absorption also in the small intestine. The fiber attracts water in the large intestine, and that's been very beneficial in that we can reabsorb some of that water before it's lost in our waste products. FOMAP, so that's an acronym for fermentable oligosaccharides disaccharides, monosaccharides, and polyols, which happen in the large intestine, and for some people are more sensitive than others in the undigested portions of the carbohydrate could cause gas and bloating, and it varies from person to person how sensitive they are. And so the acronym applies to certain foods that may have low groupings of this type of material. So individuals that are more sensitive can stay away from certain foods, giving them these symptoms. Maltose, sucrase, lactase, and pancreatic amylase. So those are all enzymes, and they're present in the small intestine. A lot of the digestion taking place, as we know, in the small intestine, in particular, right at the top of the small intestine, called the duodenum. Fermentation of short-chain fatty acids that take place in the large intestine. These are being found as important molecules that we reabsorb and could bolster the health of our immune system. Important stuff. So this is a mapping that we've seen before, comparing digestion of starch and the what happens to fiber going through the GI tract. And you'll see step by step, starting in the mouth with a little bit of digestion from amylase in the oral cavity. In the stomach, the fiber can act as a delay, improving digestion. And in the small intestine, pancreatic amylases are delivered. So the starches and also the disaccharides broken down to all the way down, in most cases, to their monosaccharides. And fiber resistant throughout the GI tract until it's in the large intestine, in which bacterial enzymes could do some digestion of that material. In some cases, creating healthy things like the short chain fatty acids, and in some cases, for sensitive people, might produce excess gas. Carbohydrate, we've seen there's different modes of digestion for carbohydrate. There's active transport that has little places where the substrate reaches in the inside of the GI tract and then is absorbed into the cells, and then toward where they're going to be absorbed into the bloodstream. Also, for some facilitated diffusion, with simpler absorption. Facilitated as for more complicated molecules that require some energy. And the bloodstream, as it goes through the liver, one important conversion is fructose to galactose. So the villi that we've seen before, the huge surface area that that will absorb the monosaccharides, and monosaccharides being water soluble, will go right into the bloodstream and then be transferred toward to the liver. The liver will convert monosaccharides to glucose. It might store a lot of that glucose as glycogen, but also will send out glucose when the body needs the energy substrate. Lactose intolerance, this is something that many people have to some degree. That is the lack of the ability to digest all the disaccharide lactose before it gets to the large intestine. The lactase activity is declines with age. Symptoms of lactose intolerance are bloating, could be diarrhea, could be gas, and it's thought that it might have a genetic component. So people with known lactose intolerance could take a few different measures. It could substitute dairy with other similar products to get those nutrients. There's lots of different types of milk these days, all kinds of nut milk, soy milk, that kind of thing. Fermented milk products ferment a lot of the lactose in them. So for comparison, we see here some foods that yogurt. So yogurt does not have a low amount of lactose, as some might think. It has about the same as milk. Ice cream, cottage cheese, all these are relatively high in lactose. So using glucose for energy. So energy for storing, reaction for storing glucose as glycogen. Well, where does that take place? That's called condensation. Preferred source of carbohydrate, glucose for brain and nerve. The reaction for breaking down glycogen to glucose, that is hydrolysis. Where is about a quarter of the glycogen stored? That's in the muscles, and the rest are in the liver. Complete breakdown of glucose yields, that's water and CO2, and energy, as we'll see later on. Amino acids of proteins may be converted to glucose by a process called gluconeogenesis. And this is a special situation when glucose is not available in the body for energy, and amino acids and even proteins could be converted. It's not desirable, but could be converted to glucose in that situation. That's the importance of glucose. So sometimes we will just forfeit and give away some protein to make sure that we have glucose until it's supplied in the diet. And so fat can also be substituted for a carbohydrate for a short amount of time, and those things that are produced are called ketones. They're from fat, and they could be used as a source of energy, except it's not a good source of energy for brain or nerve cells. There's a limitation there, but it's a substitute until carbohydrate is supplied in adequate amount. Carbohydrate is needed to prevent this ketosis, because excess and long-term ketosis could lead to other problems like increasing the acidity of the body that could be dangerous. When glucose is abundant and glycogen stores are full, the liver converts glucose to fat. So our blood glucose level and maintaining at within the normal range is extremely important for normal functioning. Um, the our our food is what helps us maintain a constant glucose level, and so that's coming right from the intestine through the liver, but also from liver stores of glycogen. In the absence of food intake of glucose, we have that storage of glycogen while that's still around. The control of blood glucose is by a couple of hormones. The first one is insulin, and insulin is signaled to be put out when glucose is high, and we want to get the glucose into cells. And so the pancreas is signaled to put out glucose, and that makes cells, muscle cells, and others open up to and permeable to let in glucose. If the bloodstream is low in glucose, then another hormone is put out, also by the pancreas, called glucagon, and that signals to wherever glycogen is stored to let glucose out into the bloodstream and go into the general, to be distributed throughout the body. Epinephrine plays a role in doing this also. And that homeostasis, that control of blood glucose, is shown in this figure. On the left, high blood glucose signals the pancreas to secrete insulin. The insulin stimulates glucose from the blood, uptake from the blood into the cells. Also, storage of glycogen and conversion of, if there's excess glucose beyond being stored or used, then store that glucose as fat. It's our body's protection for times that we don't have glucose available. We'll have some storage. And in the end, the blood glucose is lowered. And then when that's happening, we get that feedback loop saying we don't need any more insulin produced or excreted. On the other side of the figure here, low blood glucose signals pancreas to secrete glucagon. The glucagon stimulates breakdown of glycogen from the liver and release into the blood, and therefore raises the blood glucose, and then glucagon secretion is inhibited. Balancing within a normal range of blood glucose, extremely important. One, just to maintain our energy and normal activity, control of our involuntary actions, because we need the glucose to produce ATP, which is our energy currency. When there's problems with this maintaining normal range, whether high or whether low, there's different things that different problems that could occur. The extreme condition when insulin is not adequate or ineffective is known as diabetes, and there's two types of diabetes. One is when an inadequate amount of insulin is produced and secreted, and that's type 1. The second type is when insulin is produced but it's not effective at the cells. That ineffective at the cells used to be called adult onset type 2 diabetes, but now the occurrence is much greater, and even greater in younger people. On the other side of this spectrum is hypoglycemia. That's where there's inability to maintain normal blood glucose. It's too low. And there could be various causes for that, but that's the other side of the spectrum. Low blood glucose. High blood glucose is a problem because it becomes inflammatory. Long periods of high glucose is inflammatory and could be the initiation of other chronic problems. And when we get to food, we think of glycemic index, glycemic load. Glycemic response refers to the speed of glucose absorption, blood glucose levels, and then returns to normal. So glycemic response is a response to the source of glucose we take in food. Apples, corn, tortillas, and rolled oats are examples of food with low glycemic response. Watermelon, white rice cause blood glucose to rise rapidly. Following this, blood glucose levels plunge. So foods are not equal in how we respond to the carbohydrate in them. So it's important to understand that. Here's some information on glycemic index and glycemic load, some definitions. Glycemic index was a method to classify foods according to their potential for raising blood glucose as determined by their rate of absorption. Glycemic load is a method of using that information, glycemic index, to understand the interrelated effects of glucose and insulin. So glycemic load takes into effect both the glycemic index and the presence of that carbohydrate in the food. And there's numbers around this, so one could evaluate this. So here, as examples of if we were to take these food items, apple, watermelon, white rice, and sugar, and find in scientific tables their glycemic index number, and then how many carbohydrates are in a serving of that food. So the serving size is important. And then there's a calculation we do to come up with glycemic load. And this glycemic load number we compare to a table and see whether it's a high glycemic load or a low glycemic load or a moderate glycemic load. So we would think about this in diet planning and how we disperse our foods. We would not want to eat a lot of the high glycemic load food together. We would want to disperse them with other lower glycemic load foods. So it might be surprising that you might think that the apple and watermelon and even sugar is the high glycemic load. But when taken into account the total carbs in a serving, it is the white rice that's the high glycemic load. So here's a figure showing from high glycemic load foods on the bottom, such as white bread, White bread is among the highest glycemic load, so a serving of white bread is extremely quickly digested and absorbed, and we get a high glycemic spike into the bloodstream with white bread. Same, but to a lesser extent with white potato, cornflakes, and then all the way up to low glycemic foods, some nuts, peanuts are legumes, and nuts and soybean, and other kinds of beans. And in the middle, a whole lot of other different kinds of foods. So this glycemic response, not really thought about too commonly, but is very, very important. We do ideally want to maintain throughout the way a normal blood glucose and not have these large swings in our glucose levels, such as the blue line here, doing a huge spike and then quick absorption, and then we get a dip below normal. And although that's better than low glycemic response, low glycemic response is more ideal. We get some increase, but then it still does not go below the normal blood glucose level, the desirable level. Sources of sugar are prevalent in our process. A lot of our processed foods. Why? Well, to many people, maybe most, it's a desirable thing. Sweet, we all have to some extent a sweet tooth, but that has to be kind of moderated and dispersed among lower glycemic foods, because we do have this element of growing population of overweight and obesity, and some of it's attributed to sugar and highly processed foods, such as having the high fructose corn syrup in a lot of ultra processed and processed foods. And when we get these kind of calories without much other nutrients, so-called empty calories, or lack of nutrient-dense foods in the diet, then we have the health effects of high sugar. Most people realize that dental caries that sugar initiates, that is bacteria fermenting sugar on teeth, producing acid that erodes the enamel of food, causing problems in teeth and gum. Also, sticky foods, frequency of food consumption, foods and beverages with a lot of added sugar. And here's how the problem starts with dental caries on the enamel. If there's a dental carie, we might call it a cavity. It is actually a cavity that forms, and then bacteria can continue to go further into a tooth and infect and do damage into the lower gum, and even get to blood vessels and cause a bunch of problems. So what's the recommendation for added sugar to the diet? Now we know that food labels have been amplified a little bit, improved by putting more clearly how much sugar is added. And the recommendation is 10% less than 10% of calories per day coming from added sugar. But not everybody's going to do that calculation. But if you take into account and just monitor over some days of where added sugar is coming from in one's eating pattern, then you might be able to know how to modify it and take heed of these recommendations. This was from the last Dietary Guidelines for America, urging that below 10% of added sugar. So that, as I said there, the updated food labels, that is food, the nutritional facts on packaged foods does require to have added food specified, and how much is that of a percent of calories of the day. And we know that, remember that food labels are based on a 2,000 kcal intake per day, kind of an estimated average for a person. One might be lower, one might be higher, but it's an estimated average. So the DRI for sugars, again, less than 10%. It's a dietary recommended intakes. There's no upper limit established for sugar. What's a strategy to satisfy a sweet tooth without getting that extra above 10% kcals added sugar? Sugar substitutes, more recently going toward natural products. Stevia has recently become a general recognized as safe product. Others are sugar alcohols, which are sweet, but they're not absorbed. However, there's some side effects in that they could be digested in our lower GI tract by our microflora and cause gas and diarrhea. Okay, now we come to the fibers, starch and fibers. And whole grains are the best source of starch and fibers. They're shown to have beneficial effects in protecting us from heart disease, especially what's called the soluble fibers. And in general, just having these decreasing disease risks. And what are these in particular? So lower blood pressure, reduced inflammation, improved blood lipids. What does that protect against? That's heart disease. Slowed glucose absorption that we were just talking about. That would be beneficial to protect against diabetes. Increased stool weight, prevent constipation, and reduced transit time. That would be generally called gut health. And diluting, binding, and removing harmful agents, and production of short-chain fatty acids. And that would be called under the protection from colon cancer. So benefits of fiber in the diet. And this table talks about sources of the different kinds of fiber. See here, things like whole grains like barley, oats, oat bran, rye, legumes, and seaweeds, seeds. And what do they provide? They're pectins and gums, psyllium, hemicellulose. These are the particular soluble fibers. and the preventative actions that we just mentioned, and the probable health benefits here on the right. And these insoluble, less fermentable fibers, they're still beneficial, but they're a little less, they're more clumped. They're not as available for the microbes to perhaps metabolize and create those beneficial short-chain fatty acids that are reabsorbed with some benefits. But there's still a lot of benefits in even the insoluble fiber. The DRI for carbohydrates is 130 grams per day for carbohydrates. For fiber, daily value of 28 grams per day for 2,000 kcal intake per day. 28 grams of fiber is a challenge for most people. You'll see that in your eating pattern accounting. 28 grams is a challenge to get. You really have to make an effort to have certain foods in your regular eating pattern to get that. And to do that, we include these things from the diet group, from the grains group. There's some examples from the vegetable group, from the fruits group, and legumes group. Suggested from grains, an ounce of grains could have up to 15 grams of carbohydrate. Vegetables, 15 grams, and within them, we can get a certain percentage as fiber. And look closely for the dietary fiber. Here's an example. Here's a whole grain bread label, and a wheat grain, and a low carb grain. And if we look across how much dietary fiber is in a slice, there's 2 grams in this whole grain. In this natural, there's only 1 gram. And in this multi-fiber low carb is 3 grams. So still not a whole lot of fiber in processed foods like white bread, like bread. And finally, a little highlight here. The intake of carbohydrates from 1960 has been on a steady increase. You can see the scales here, about the same slope for men and women, higher amount in general for the body weight, but the same slope of intake. And that may have come from in the 60s, the anti-fat or the low-fat movement made food manufacturers use a lot more carbohydrate in their foods. It was taking out the fat, took out a lot of flavor, so it had to be replaced with some other ingredient. So carbohydrate became the thing, and unfortunately led to a lot of increased added sugar at the same time. Is a bar graph showing years 1977 to 78 in the distribution of macronutrients. You see that carbohydrate has increased to more than 50% of our intake, where it was very similar to fat in the previous years shown there. Protein stayed the same, but just this change in substituting carbohydrate for fat. In recent years, however, the recommendations are to try to switch that back, to increase fat. That fat is not bad. It's just the type of fat you want and how it's distributed during the day. The beneficial fat is the better, and to reduce the simple carbohydrate, especially the added sugars. So as we said, the increased consumption of added sugars could be mainly partially attributed to sugar-sweetened beverages. May have increased the need for having things sweet. The use of fructose more and more in foods is a worry to nutrition scientists because they believe it's metabolized differently than glucose and not in a good way. Because fructose in the liver seems to be converted right to fat and not converted as efficiently to glucose as previously thought. And converting to a lot of fat in the liver is a problem. Could be the start of fatty liver syndrome. Beverages provide kcals without satisfying hunger, and they're also the form that the carbohydrate is important too. Liquid carbohydrate or like sweetened beverages can be consumed much faster, easier than when it's a solid. So it might take in more of that sugar faster in a liquid form. Insulin's role is critical. It's it's an anabolic steroid, meaning it makes provides for making of glycogen, absorbing of glucose out of the bloodstream. Insulin resistance is very dangerous. This could lead to obesity and eventually worse to diabetes and other chronic diseases. Glycemic index and body weight are important considerations. So that's our start in starting to look at the macronutrients. We just looked at carbohydrate and its form. Not on here is protein, and we'll venture into those in coming chapters.